Last bit of notes. We are going to talk about an absolute value graph. So an absolute value function has a very specific shape to it. An absolute value function is either a V or an A. So it's either going to have two linear functions opening upwards or two linear functions opening downwards, which makes its derivative a little difficult to find. So there's a nice easy trick to it. Split the graph in half. For absolute value functions, split the graph in half. You're going to first find the vertex, which is always located right here in the function at h comma k. And then you need to determine if this is a positive v. So determine if it is a positive opening v or a negative opening a. Okay, so determine if it is opening upwards, being positive is a v, downwards being negative is an a shape. Now, that positive or negative comes from the sign outside the absolute value. So that green star outside the absolute value is what tells me whether or not I will have a positive V or a negative A. So this is pretty straightforward. We are going to find where the graph splits by cutting it in half at its vertex, and then we're going to state the slopes of the linear functions on either side. So we are going to treat these as two separate entities and say that there is a function to the left. So I'm going to call this f, and we are going to contrast it with the function to the right, g. And they will have the same absolute value slope, but they will have different signs of slope because absolute value is symmetric. So it's got the same absolute value slope, but one will be positive, one will be negative. So let's actually put this to practice here. F of x equals absolute value of x plus 7. So right away, I state the vertex as -7, 0, because the vertex form is x minus h. So plus 7 means that you did minus a negative, so it's -7. And then k is on the outside. There's nothing on the outside, so k is 0. This is a positive v because the absolute value is positive, and the vertex is right there at -7, 0. To the left of the vertex, that is a negative linear function. To the right of the vertex is a positive linear function, and they both have the same slope. Look right there, mx, that slope on the x is a 1. So to the left, we are dealing with a -1 slope. To the right, we are dealing with a positive 1 slope. Here's how that gets written up. We write that up by saying f prime of x equals -1 for the left side. That left side comes from saying x is less than -7. As a matter of fact, I can take this down here. There we go. And then we can add the next part, the positive right-hand side, and say f prime of x equals +1. Remember, f prime of x is the derivative. That's the slope of the tangent lines. The slope of a linear function is just whatever the heck its slope is, so it doesn't really change in between. For x is greater than -7. Now, here's the kicker. F prime of x does not exist for x equals -7 because the limit as x approaches -7 from the left of f prime of x does not equal the limit as x approaches -7 from the right for f prime of x. So whenever we have the situation here where the left side does not match the right side, and specifically dealing with slopes, I'm going to put this down here, okay? Whenever we have the left side slope, right here, left side slope, not matching the right side slope, there is a point of non-differentiability, point of non-differentiability at x equals -7. And that's our summary for absolute value. Not actually as bad as it looks. It's more wordy than mathy, but it's pretty straightforward when it comes to the math. You do need to have a solid working knowledge of how to graph absolute value functions, but that's why we're reviewing them now. So let's go ahead and look at the other problem that we've got up here. If you need to pause and write this down, pause and write it down. But our second example is going to have the same pattern. So we've got a vertex of, oh, this one looks like it's a +9 and a 3. If you need to rewrite this as x minus 9, here's our +9, 3. And this is a positive V graph. So I'm just going to sketch around right over here. Should put arrows on this number 1 as well. So we'll just say that this is at 9, 3. The beauty of a sketch is that it doesn't have to be perfect. It just has to have the critical elements in it, maxes, mins, and intercepts. So I've got my minimum vertex labeled. I've got the correct direction and shape. Now I'm going to write up the left side and the right side. So the left side says that the slope, or f prime of x, is -1. Again, just no coefficient on the x means that there's a slope of 1. We do need to describe this for x is less than 9. Versus the right side, f prime of x equals +1 for x is greater than 9. And then I'll go ahead and say this. We can rewrite that statement that we have down at the bottom for number 1, and we can just say very simply, f of x is non-differentiable. I feel like I'm differentiable, there we go, at x equals 9. Now, if you want the thorough explanation, add the thorough explanation. The limit as x approaches 9 from the left of the slopes, remember f prime of x is talking about the slopes, it does not equal the limit as x approaches 9 from the right of the slopes. And there we go. First 2 problems of absolute value done, and I only have 3 more. So I'm going to pause here, give you a video break, and then we will resume with our next video.